Welcome to Module 2 of the Six Sigma Institute's Lean Six Sigma Certification Curriculum, which follows both the Council for Six Sigma Certification and International Association for Six Sigma Certification bodies of knowledge. A full copy of the Council for Six Sigma Certification's Book of Knowledge can be downloaded from the course description section for free. In this module, we will be discussing the history and application of Six Sigma. This module will take approximately 80 minutes to complete. At the end of this module, there will be a 5-question quiz on the topics discussed, which you can complete at your own time. You will also find several Six Sigma tools that you can download, including a Plan, Do, Check, Act template and a basic control chart template, both of which are Excel files. The roots of statistical process control, which provide a backbone for Six Sigma methods, began with the development of the normal curve by Carl Friedrich Gauss in the 19th century. In this section, we will be taking a closer look at the development of statistical process control and discuss Walter Shewhart and Edward Deming's contributions to quality control. We will introduce you to the concept of control charts, the Plan, Do, Check, Act cycle, and why post-war Japan was so crucial to the development of the quality control methods we use today in Lean and Six Sigma. While there are quality programs that seek to achieve the same goals as Six Sigma, like reducing errors and defects, making processes more efficient, improving customer satisfaction, and boosting profits, they focus on achieving a specific goal. The program either runs forever, constantly working towards the same goal, or it achieves the end goal and must be reset for a new goal. Lean Six Sigma's focus on integrating a culture of continuous process improvement into an organization is what sets it apart from many other programs that are available today. Walter Andrew Shewhart was an American physicist, engineer, and statistician. He is known as the father of statistical quality control. On May 16th of 1924, Dr. Shewhart prepared a one-page memo which contained all of the essential principles and considerations which are involved in what we know today as process quality control. It also included a schematic control chart which covered a third of the page. He pointed out the importance of reducing variation in a manufacturing process and the understanding that continual process adjustment in reaction to non-conformance actually increased variation and degraded the quality. Shewhart framed the problem in terms of assignable and chance-caused variation and introduced the control chart as a tool for distinguishing between the two. He stressed that a process will never produce a normal distribution curve due to the inherent chance-caused variations, and should instead be brought into a state of statistical control. The control chart is simply a graph used to study how a process changes over time. Data points are plotted in time order. They will always have a central line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are calculated from historical data. By comparing your current data to these lines, you can draw conclusions about whether the process variation is consistent and in control, or if it is unpredictable and out of control. Whether there are special cause variations in the process. Control charts for variable data are used in pairs. The top chart shows the average, while the bottom chart shows the range. Attribute data, unlike variable data, are displayed using only a single control chart. William Edwards Deming was an American engineer, statistician, professor, author, lecturer, and management consultant. While working under General Douglas MacArthur as a census consultant to the Japanese government, He was asked to teach a short seminar on statistical process control methods to the radio corps. During this visit, he was invited by the Union of Japanese Scientists and Engineers to talk directly to Japanese business leaders about his theories of management. But Deming is best known for his work in Japan after World War II, where he gave lectures on statistical product quality administration. Many in Japan credited Deming as one of the inspirations for what has become known as the Japanese post-war economic miracle of the 1950s to 1960s, when Japan rose from the ashes of war on the road to becoming the second largest economy in the world. The Plan Do Check Act cycle was initially created by Dr. Shewhart as the Plan Do Study Act cycle. Later in Deming's career, he modified the cycle to PDCA because he felt that check emphasized inspection over analysis. The concept of the Plan Do Check Act cycle is based on the scientific method, which can be written as hypothesis experiment evaluation, or Plan Do Check. A fundamental principle of the scientific method and the Plan Do Check Act cycle is iteration. Once a hypothesis is confirmed or negated, executing the cycle again will extend the knowledge further. Repeating the Plan Do Check Act cycle can bring its users closer to the goal of statistically perfect operational output. In practice, more than half of the time is spent in the planning phase, where you define the problem and seek the solution. Next, you implement that plan and then check to see if the implementation resulted in an improvement to the process. If the solution is viable, then you act by integrating the solution into the standard operating procedures. But if not, well, then you just start the cycle all over again. The Japanese economic miracle was a period of economic growth in Japan between the World War II era and the end of the Cold War. During this boom, Japan became the world's second largest economy. Dr. Juran predicted the quality of Japanese goods would overtake the quality of goods produced in the United States by the mid 1970s because of Japan's economic growth. Japanese manufacturers focused on improving all organizational processes through the people who use them. As a result, Japan was able to produce higher quality exports at lower prices. And this ultimately triggered the quality crisis of the late 1970s and early 1980s. America responded with total quality management, which did very little to improve quality. Several other initiatives would soon follow, like ISO 9000 and the Malcolm Baldrige Quality Award. Eventually, it was Motorola who ended the quality crisis with the development of Six Sigma in the mid 1980s. Toyota's leadership initially visited the concept of quality prior to World War II, but improved performance and efficiency became a critical goal to Japan's post-war economic miracle. In this section, we will discuss continuous process improvement through the Toyota production system and the lean process management. We will take a closer look at Jidoka and the just-in-time manufacturing process. Several individuals were instrumental in the ultimate development of the Toyota production system. They infused the process with automated machinery, quality controls to keep defects from occurring, and efficiency tools that had not been applied with such detail and consistency. Toyota had previous factory experience. In his previous job, he added efficiencies to processes in textile mills through conveyor and other automated systems. Toyota introduced the same concept on certain lines in the Toyota manufacturing process. Later, his son and Taichi Ono introduced concepts known as just-in-time and Jidoka, which are the pillars of the Toyota production system. The principles that drive the Toyota production system include defining customer values, identifying the value stream, and waste within a process, as well as creating a continuous process flow and working to reduce the number of steps it takes to reach customer satisfaction. Jidoka is a principle that creates control of defects inside a business process. Instead of identifying defects at the end of the production line and attempting to trace errors back to the source, Jidoka demands that a process stop as soon as errors are detected, so improvements or troubleshooting can happen immediately. For Jidoka to work properly, machines are often equipped to recognize bad outputs from good outputs. The machines are also equipped with a notification of some type to spark human interaction in the process when things go awry. In using the concept of Jidoka, as soon as we detect an abnormality, we need to immediately stop the process to prevent any further reoccurrences. We fix or correct the immediate cause of the abnormality. We basically put a band-aid on it. Then after we restart the process, we investigate the root cause and create a permanent fix for the issue. Just in time is not a technique. Rather, it is a management philosophy that originally referred to the production of goods to meet customer demand exactly at the time it was placed, with quality and in the quantity demanded. The customer can either be the end user, a middleman, or even another process. It is a concept that has come to mean producing with the least waste possible. The just-in-time philosophy focuses on continuous improvement of the process and elimination of waste from that process, keeping the work area clean and organized by implementing 5S and a smooth workflow of the production line with minimal setup times. To accomplish this, we use the Kanban signals and encodes to signal problems and Jidoka to fix those abnormalities. The principles of the Toyota production system were brought to the United States and introduced as lean process management. Because of their similarities and how well they work together, today we have combined Lean and Six Sigma into a single methodology. Nevertheless, Lean is based on 5 key values. Firstly, the value is always defined by the customer's need and not by the organization. In order to identify these needs, we have to map the value stream. This mapping allows us to identify any waste in the process so it can be removed. It also helps us to identify bottlenecks so that we can create a continuous flow through the process as the products are pulled through it. Lastly, we continually work to reduce the number of steps and time it takes to reach customer satisfaction, to seek that level of statistical process perfection. It is important to always note that lean management is highly concerned with removing waste from any process. Waste increases costs and time spent on a process, making it undesirable in any form. By applying lean concepts, a new company began creating televisions that demonstrated 1/20th of the number of defects as Motorola's own television sets using their own plant. In this section, we will discuss the development of Six Sigma at Motorola in the 1980s and take a deeper look at the founders of the methodology and the initial impact Six Sigma made on Motorola's bottom line. We will discuss Bob Gavin's decision as CEO of Motorola to create change and the efforts that Bill Smith and Mikel Harry put forth to create the Six Sigma quality improvement method. In the 1980s, a Japanese company took over a Motorola television manufacturing plant. And by applying lean concepts, this new company began creating televisions that demonstrated 1/20th the number of defects as Motorola's own television sets. Bob Gavin, the CEO of Motorola, issued a challenge to his team. He wanted to see an improvement in quality and production, not just any improvement. He wanted a tenfold improvement in 5 years. Engineer Bill Smith and a new addition to the Motorola team, Mikel Harry, began to work on the problem. Not only did they meet Gavin's requirements, but they continued to refine the methodology over the next few decades and ultimately saved Motorola $16 billion through continuous process improvements over the first 12 years alone. William Bill Smith was an engineer at Motorola and has been often referred to as the father of Six Sigma. Smith joined Motorola in 1987 after having worked in engineering and quality assurance for more than 35 years. Together, along with Mikel Harry, the team brought Japanese quality control methods to the United States. And although they significantly improved the quality of Motorola's product line, it was not until Smith's recommendation for using the Six Sigma calculation as a common metric that those improvement initiatives could be compared and deemed successful. Six Sigma was used to describe an expected level of design margin and product quality. Smith and Harry worked together to come up with a four-stage problem-solving approach. These stages included measure, analyze, improve, and control, which became the cornerstone of the Six Sigma process. Later, the define phase would be added, creating the five-phase DMAC approach that we know and use today. Mikel Harry was a statistician, quality expert, and author who, along with Bill Smith, is credited for developing Six Sigma. While he is sometimes referred to as the father of Six Sigma, it is important to remember that it was Smith who recommended using Sigma as a common metric to compare quality initiatives. After Bob Galvin instructed the team to share Six Sigma with the world, Harry was the one who wrote the first Six Sigma book of knowledge and even opened the first institute to teach Six Sigma outside of Motorola. While at ABB, he added financial metrics to the methodology because these were important to business leaders who make the decisions to support an initiative. He was ultimately responsible for introducing Six Sigma to ABB, Allied Signal, and eventually through Allied Signal CEO to General Electric, where Jack Welch became one of the most prominent champions of the methods we use today. Six Sigma was born in the mid-1980s at Motorola in response to the quality crisis. Bill Smith and Mikel Harry spent more than a decade developing and refining it, during which its use of the concept of continuous improvement ultimately led to the company saving more than $16 billion in the first 12 years. After its success within Motorola, Bob Galvin wanted to share Six Sigma with the world, and Mikel Harry did this by creating the first Six Sigma Book of Knowledge and opening the first training institute outside of Motorola. Today, while there are three major organizations, the Council for Six Sigma Certification, the International Association for Six Sigma Certification, and the American Standards for Quality, who provide their own bodies of knowledge, there is no centralized accreditation system in place, as the knowledge is passed down from black belts, much like a master trains an apprentice. After leaving Motorola, Dr. Harry joined ABB and introduced the company to Six Sigma. Later, with the help of Richard Schroeder, Six Sigma would be introduced to Allied Signal and eventually GE. In this section, we will take a closer look at what happened after Mikel Harry left Motorola and how Six Sigma began to spread to other organizations. We will discuss ABB and Harry's partnership with Richard Schroeder to improve Six Sigma and open the first institute outside of Motorola. We will discuss how Jack Welch, the CEO of General Electric, learned about Six Sigma and why he eventually became one of its biggest champions. After leaving Motorola, Dr. Harry joined ABB, where he worked with Richard Schroeder. Schroeder would eventually become a Six Sigma champion, and the two co-founded the Six Sigma Academy. At ABB, Harry came to realize a key idea in the evolution of Six Sigma, that business or profits in some way came before quality. Quality, in fact, was a driving factor of businesses. Customers didn't make purchases if quality was poor. Because the individuals with the ability to decide in favor of Six Sigma initiatives were highly motivated by dollars, Harry incorporated financial tactics into the Six Sigma methodology. For the first time, the method was focused on the bottom line as a primary goal, with other concerns and goals stemming from financially led goals. Richard Schroeder even helped Mikel Harry to write numerous books on Six Sigma and quality management. Eventually, Schroeder opened his own consulting business where he has continued to use Six Sigma to help companies like General Motors, GlaxoSmithKline, Rockwell, Dow, DuPont, Bombardier, American Express, the Mayo Clinic, Seagate, Johnson Controls, and Nokia in order to reduce cycle times, improve quality, and increase process capabilities. He is still an active champion of Six Sigma and has a long list of organizations he has consulted for since the founding of the Six Sigma Academy back in the 1990s. In 1993, both Schroeder and Harry changed jobs, joining the team at Allied Signal. Allied Signal CEO at the time was Larry Bossidy, who was interested in Six Sigma, but realized that executives and other high-level leaders experienced knowledge barriers while attempting to interact and collaborate with analysts, process engineers, and Six Sigma experts. Bossidy suggested that leadership at a company had to be well versed in Six Sigma to pick the right projects for success and support those projects on a company wide basis in order to ensure that success. Through Mikel Harry, a system for educating executive leaders was created, and in conjunction with others at Allied Signal, he developed a system that allowed Six Sigma to be effectively deployed by leadership throughout an entire organization. Prior to learning about Six Sigma, Jack Welch, the CEO of General Electric, had stated that he was not a proponent of quality measures. He had even criticized quality programs on numerous occasions as being heavy-handed approaches that did little to deliver results. But in 1995, Welch invited the CEO of Allied Signal to speak at a corporate meeting. And although he was not a fan of quality programs, he nevertheless requested an analysis regarding the benefits of implementing Six Sigma at General Electric. Welch did not contribute to Six Sigma by introducing new tools or process controls. Rather, he demonstrated how a leader should approach Six Sigma. In doing so, he quickly became one of the loudest Six Sigma champions ever. In 1995, Bossidy, the CEO of Allied Signal, presented the findings of a Six Sigma analysis of General Electric to a corporate meeting, where he showed how the company at the time was only performing at a 3 to 4 Sigma level, and that the potential savings of improving to a Six Sigma level was between $7 and $10 billion. Welch decided to implement Six Sigma at General Electric, and in doing so, he made the company historically successful by tying Six Sigma goals to employee reward structures. Employees were no longer only compensated based on financial performance factors, they were also evaluated based on Six Sigma performance. Suddenly, employees at every level had a personal reason to become involved in continuous process improvement, and employees and managers were supplied with Six Sigma training in order to succeed. Champions are upper level managers who lead the execution of the Lean Six Sigma deployment plans for the company. That makes it one of the most critical roles in any successful Lean Six Sigma improvement initiative. Guided by the direction set forth by the executive team, champions select the projects, determine who's trained as black belts or green belts, review progress, and mentor the black belts, green belts in order for the deployment to be effective. Because of this, it is important that champions be knowledgeable about Six Sigma and its deployment within their organization. Some of them are even black belts, while others go through Six Sigma champion training, which provides them with the basic managerial and technical knowledge necessary to facilitate the leadership and deployment of the Six Sigma strategy. Following the success of corporations such as General Electric and Motorola, companies across the country rushed to implement Six Sigma. In this section, we will discuss the continued growth of Six Sigma, as well as the many myths surrounding its implementation. These myths generally fall in one of two categories. They are either spread by those who have no knowledge of Six Sigma or those who dislike any form of quality program as a result of bad previous experiences, or they are spread by those who are overly enthusiastic about Six Sigma and tend to oversell what can be accomplished by using the methodology. Because of poor execution caused by a rush to implement, there are some myths surrounding the implementation of Six Sigma within an organization. There are those who have had bad experiences with other quality controlled methods and programs. Some of these programs do focus on metrics and ignore the fact that common sense and experience still play an important role in operating a business. There are others that believe that it is just too expensive to conduct, let alone implement any form of Six Sigma project within their organizations. While there are still some that are overly zealous in their interpretation of what Six Sigma is capable of accomplishing. Some say that Six Sigma is solely concerned with metrics and ignores common sense, but the opposite is actually true. Six Sigma often starts with traditional common sense ideas, often arrived at through brainstorming, and validates those assumptions with data. The reason for this myth is twofold. First off, managers and others who are used to making calls without being questioned are suddenly questioned in a Six Sigma environment. Not only are they questioned, but hard data sometimes prove them wrong. Second, in some cases, data is improperly used to support conclusions that are against common sense or tradition. When those conclusions turn out to be faulty, it is easy to blame the process or Six Sigma because there is a lack of adequate understanding of the statistical theories that are involved. Others say that Six Sigma is just too expensive. While enterprise-wide adoption of Six Sigma can be costly at first, due mostly in part to training needs, by slowly integrating the concepts into a company, the cost of adoption can be reduced and spread out across a greater period of time. Many smaller organizations will have to balance how they adopt Six Sigma by focusing on their budgetary concerns. But as long as Six Sigma is implemented correctly within an organization, it generally leads to savings that will more than cover the initial investment of the organization. Then there are those that insist that Six Sigma can fix anything. Opposite to the naysayers are the Six Sigma cheerleaders who believe they can apply the method like a solve to any problem. While Six Sigma can be applied to any process related problem, it is not always relevant to problems of culture or people. If morale, for example, or other human resources problems are at the root of an issue, then statistics cannot help. That is not to say that Six Sigma cannot help, because if that low morale issue is a direct result of a process that is difficult to work with or that is performing poorly, Six Sigma can be used to improve the process and thereby improve employee morale. When I introduced myself, I explained that I was first introduced to Six Sigma while working at a call center. My project ended up failing because the root cause to the issue was morale related. The operations manager treated all of the agents as if they were nothing more than indentured servants, always criticizing them and insisting that they cannot be trusted because all of them were liars. The only way to fix the issue was to remove the operations manager and retrain the entire floor. Leadership within the company was not willing to take this step because of the fact that there is so much politics involved in hiring that operations manager for the position. Six Sigma is applied via a controlled project selection and management process. Six Sigma teams attempt to quantify how broken a process is and how much it might cost to address the problem. In this section, we will discuss how the Six Sigma knowledge is applied within an organization. And we will take a closer look at the different levels of certification, including the white belt, yellow belt, green belt, black belt, and even the Master Black Belt. And we will look into the concepts that will be taught at each level and what is expected of each team member level. We will also discuss the process of certification exams and the issuance of certificates. There are 6 levels of Six Sigma certification that starts with the white belt. White belts have just basic knowledge of Six Sigma and can assist in teams but do not know anything about participating in a project directly. The lowest level for an active team member is the yellow belt. They are managed in teams by green belts, who are generally middle management level employees within an organization. The green belts can even run small initiatives because they have learned how to use most of the tools in the Six Sigma toolkit. Then there are black belts, who oversee projects within an organization. They can be middle or even upper management, or even contractual consultants brought in by the organization to oversee a specific initiative. Then you have the master black belt, who is responsible for all of the ongoing projects within an organization, and is generally a member of upper management who is responsible for training all lower levels. Lastly, there are the champions, the decision makers who make the things happen and advance the projects within the organization. A certified Six Sigma white belt is familiar with the basic tenets of the Six Sigma methodology, though they aren't often regular members of process improvement teams. White belt training is a good introduction to the Six Sigma methodology for auxiliary staff members within an organization and can provide the information necessary for understanding why project teams do what they do. The training lets employees review project processes, understand information presented in milestone meetings, and better participate in project selection processes. White belt training can also be used across all levels of employees when organizations are attempting to implement a Six Sigma culture. It is worth noting that white belt training usually only provides a very basic introduction and overflow of Six Sigma. So much so that not all Six Sigma professionals recognize it as a true Six Sigma certification. Yellow belt certification is a step above white belt. It is the lowest level of certification for regular Six Sigma team members. They learn the most basic information about the DMAC methodology, often used to improve processes. Yellow belts learn about the various roles, an introduction to team development and management, and even learn how to use basic Six Sigma tools like Pareto charts, run charts, scatter diagrams, and histograms. They understand the common metrics used in Six Sigma, as well as the various forms of data collection and how to conduct a measurement system analysis. At the yellow belt level, training is often geared towards understanding of the overall methodology and basic data collection. Yellow belts don't need to know how to conduct hypothesis testing, but they must understand the language of hypothesis testing and the conclusions that are drawn from such tests. Yellow belts are often employees who need to know about the overall process and why it is being implemented. There are 3 major organizations that handle Six Sigma certification, which includes the American Standards for Quality, the International Association for Six Sigma Certification, as well as the Council for Six Sigma Certification. While each of these utilizes their own bodies of knowledge, they are very similar in nature. Generally speaking, yellow belts will learn about the various roles in a Six Sigma initiative, as well as how those teams are developed and managed. They will learn how to use and understand basic quality tools such as Pareto charts, run charts, scatter diagrams, and histograms. Yellow belts even understand the common Six Sigma metrics, how to collect data, and how to conduct a measurement system analysis and a root cause analysis. They even understand the basic principles of hypothesis testing, especially when it comes to determining if their data is normal. Certified green belts work within Six Sigma teams, usually under the supervision of a black belt or master black belt. In some cases, Green belts might even lead or handle smaller projects on their own. Green belts are generally equipped with intermediate statistical analysis capabilities. They might address data and analysis concerns, help black belts apply Six Sigma tools to a project, or teach others within an organization about the overall Six Sigma methodologies. Green belts can be middle managers, business analysts, project managers, and others who have a reason to be involved regularly with process improvement initiatives, but who might not be a full-time Six Sigma expert within an organization. Sometimes, green belts are considered the worker bees of the Six Sigma methodology because they undertake most of the statistical data collection and analysis under the supervision of a certified black belt. There are three major organizations that handle Six Sigma certification, which includes the American Standards for Quality, the International Association for Six Sigma Certification, as well as the Council for Six Sigma Certification. While each of these utilize their own bodies of knowledge, they are very similar in nature. Generally speaking, green belts will learn all of the basic fundamentals taught to yellow belts, as well as have an understanding on how to conduct a failure mode and effect analysis, basic hypothesis testing, and even how to create basic control charts used in Six Sigma. They will have a general understanding of probability and the central limit theorem, as well as descriptive statistics. Green belts have to run smaller teams so they will understand project and team management, as well as how to eliminate waste and conduct Kaizen events. A certified Six Sigma black belt usually works as the project leader on process improvement projects. They might also work within management, analysis, or planning roles throughout a company. Common minimum requirements for black belt certification includes knowledge of the expansive list of Six Sigma brainstorming and project tools, the failure mode and effect analysis, probability and the central limit theorem, statistical distributions, intermediate to advanced statistics, as well as an understanding of other process improvement and quality improvements, including lean and total quality management. They also show advanced capabilities for diagramming processes, including flowcharts and value stream maps, and have the ability to use software to conduct analysis such as Excel or Minitab. There are three major organizations that handle Six Sigma certification, which includes the American Standards for Quality, the International Association for Six Sigma Certification, as well as the Council for Six Sigma Certification. And while each of these utilize their own bodies of knowledge, they are very similar in nature. Generally speaking, black belts will learn all of the basic fundamentals taught to yellow and green belts, as well as have knowledge of the expansive list of Six Sigma brainstorming and project tools. They will have an intermediate to advanced understanding of statistics and other process improvement and quality programs. Black belts have the ability to design processes, run advanced projects, and manage multiple teams simultaneously. More importantly, they will have advanced capabilities for diagramming processes, including flowcharts and value stream maps. And they will know how to use software such as Minitab and Excel to accomplish all of those tasks. The Master Black Belt is the highest certification level achievable for Six Sigma. Within a business organization, Master Black Belts usually manage black belts and green belts, consult on especially difficult project concerns, offer advice and education about challenging statistical concepts, and train others in the Six Sigma methodology. While it is possible for a green belt to train yellow belts and for a black belt to train yellow belts and green belts, most of the training is provided by or at the direction of a master black belt. However, many smaller organizations do not have their own master black belt due to the time and cost to obtain the certification. As a result, they may hire a consultant to fulfill this position. The master black belt is aptly named because they have shown that they have mastered all of the skills, methods, and tools that are used in Six Sigma. When Motorola first developed Six Sigma back in the mid-1980s, they had created their own school where Six Sigma is taught and where the exams were completed and certified. But in the mid 1990s, Bob Gavin, the CEO of Motorola, told Bill Smith and Mikel Harry to give Six Sigma to the world. Harry did just that and created the Six Sigma Academy shortly after leaving Motorola. But the Academy was never intended to be a centralized accrediting organization. As a result, there is no centralized accrediting institution when it comes to Six Sigma. There is the American Standards for Quality, the Council for Six Sigma Certification, and the International Association for Six Sigma Certification, but none of these are a centralized authority. There is a general consensus on the exams and certification. Yellow belts will generally have to take a 20-hour course and pass a 30-question exam with a 70% or greater score. Green belts need to take a 40-hour course and pass a 60-question exam, and black belts require an additional 80-hour course and a 120-question exam.